Okay, we're back. We're back with a little Zelda and Chill from Game Chops. Game Chops on YouTube. Video Games Study Lounge. This is one of their VODs. So, hope you like it. Hope I like it. Turn it down just a little bit, or actually maybe I can do this and then go like this here, because I think I turned my headset up. I think I turned my headset up to listen to Mr. Wiggly's Twitch VODs. Okay. So, when we last left off, we literally pushed this one quad through. Texture coordinates, nothing's transformed. Alright. Let's see what we can do. I'll be right back. Okay, what do we got going on here? What do we got going on? What's happening? What's happening? Bum, 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 bum. Lost Woods. We're in the Lost Woods. Dun, 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 dun. Okay. So the first thing we want to do is figure out what we want to do. Well, in the vertex shader, point size doesn't matter. Okay, so we could do in here like this. Vertex ID. So let's go like this. Negative. Because a position right now is, yeah, first of all, let's just scale it. Okay. Times 0.25. Just to show you, so that shrinks it down. Computer, there we go. So that shrinks it down to this. Step by step, we're getting there. So, and what we're actually shrinking down is this vertices right here. So 0.5 times 0.25 is going to give you, pardon me, 0.125. Okay. So we have some things to work with here in the vertex shader. So let's just do so let's leave it at that particular size. And now let's start over at negative 0.9. And for each GL vertex ID, no, instance ID. For each GL instance ID, I think that's what we want. We want to multiply times 0. So each one's going to be a radius of 0.125. So they're each 0.25. Okay. So let's just go 0.3. So we're going to take that GL instance ID, as long as I've spelled that correctly, I believe. Save that. And that should just position it more towards the left of the screen. And oh, down here. How come its Y value is way down there? Oh, because we're, okay. Let's go like this. So let's call that the X offset. And then down here, so if we wanted to add that in, you want to go because this is a vector 3 right here. So you want to go a position, wait. Actually, let's do it like this. Hold on. And let's just call it scale. Because eventually we can send that in. So it's a vector 3. And let's just put that in right here. New position. Okay, so now we want to take just the X. Okay, so new position.x equals new position.x plus X offset. See what that does. Completely gone. There's an error. Okay, I'm fine with that. Expected that, or that, a token that. Line 12. Line 12. Float X offset. Oh. Miss Scoozy. You can tell I'm in a better kind of a frame of mood to, oh, there it is. So it's over there. Okay, perfect. So now what we want to do, okay, so we've got the one instance. So we want to go into our render function and just render 6 of those. Seems innocent enough, right? Okay. Computer, don't yell. Okay. 1, 2, 3, 4, 5, 6. Boom. So now we have transformation and duplication. Excuse me. Within the vertex shader, and I have not sent in any data. Okay, so I have not sent in any data whatsoever. Whatsoever. So that's in one direction, and I'm not talking about the boy band. Alright, sorry. So 36 now. Let's go. So now let's go with X offset, that's fine. So we're going to take GL instance ID, but with the X offset what we want to do is we want to take that and mod that. Can we do that as an integer? Mod that with 6. And then multiply times 0.3. So it's going to be -9, and it's going to just do that right there. Now let's go float Y offset. Okay, we're going to go -0.9 plus GL instance ID. We're going to go divide by 6 times 0.3f. But this one, what we need to do is floor that. Excuse me. And then down here, Hard correct, Jackie. Great job, man. Hey, thank you, sir. How are you? I'm having fun. We're just beginning. We're going to explore the vertex shader and the geometry shader in detail, even if it kills me. And it probably will. I'm kidding. I'm kidding. Okay, so new position. So there's other ways to do this, but I'm going to do it like this. New position.y plus y offset. So now let's see what that does. Okay, we didn't get anything. We have an error expected. Okay, line 14. Looks like I made an error on line 14 right here. Oh, right here. There. Whoops. Don't forget the semicolon, because that makes all the difference. Good grief. Okay, so now we have 36 of them. All right. See, we have a 6 by 6. Very cool. Okay, so what we want to do, push that up a little bit, actually. Okay, and just because I want to move that over just a little bit, like that. There we go. So it's all kind of visible here. Okay. So now in the other one, what we did, Zelda and Chill, Oath to Order, from Game Chops Radio. I kind of have the radio voice, don't I? I kind of get that down. That's pretty good. Where are we at here? What was I looking for? Bum, 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 bum. Background stars. No, we're looking for background parts. I think that would have it. In the fragment shader, though. Yeah, rotate. Okay, rotate. So what we want to do is add a rotation. Actually, where's the asteroids one? Space arena background stars. Background parts. Excuse me. 7, oh, it's up here, wait. Where's the FS? Right here. Asteroids, oh here it is. Okay, I'm losing it. That's fine though. So we want to look for these. Right here, background stars. Where did I put it? I just had it. That one. Wait, that's not it. Computer, help me out here. 2D arena. Asteroids right here. Oh, Space D&D Asteroids 8. Let's open that one. Space. The heck? How long ago did I work on this? This was yesterday, I thought. I thought this was yesterday. Space. D&D. Asteroids. 8? Isn't it? Oh, this isn't it though. Oh, wait, is it because... Okay, I'm sorry. I'm thinking of this wrong. I actually do the... what I'm wanting to do is get the... what's this one? This is the one we're currently working on. This is the one we're currently working on. This one is the one that we want to... This is what we want to look at, right here. Class, Space, Arena, BK, Asteroids. Is it this one? Alright, I'm an idiot. Here we go. This is what we want. Init data. So where's the rotation applied? Rotate the grid points. Okay, so C rotation, S rotation, make the rotation, apply the rotation. Okay. So let's do that in the vertex shader here. Is that what we're doing? Let's say the rotation is... let's make it obvious. So 0.78, because I think that's 45 degrees. That might be pretty close to 45 degrees. Zero 625. Wait, what? $785. Okay, I figured that out right. There we go, 785, 45 degrees. Keep up the good work, brother. Well, thank you. Thanks for coming in. You gonna stick around, or what are you what are you up to? What are you doing? What are you doing? So the rotation there, so let's go with P cosine equals the cosine of rotation. Float P sine equals the sine of rotation. Okay, so we're pre-computing the rotation there. Let's move this down to the bottom. Offset, scale, position. There. Let's kind of set these things up like this. Okay, and then the matrix. Now what I was looking at though is the code for it. GLM matrix 2 and then that, but I had it in code there in that thing. Just going through new stuff, and this looks interesting. Cool. Yeah, I like to do interesting eye candy stuff. I'm trying to do my asteroids that I've already got, but I want to do it through the geometry shader because I think I can take a lot of the transformation off of the CPU and put it onto the GPU. Like why I didn't do that before, but it's kind of complicated, but I'm working through it here. I think we're going to get it. So let's look at, I don't really have a vertex shader where I apply space D&D Asteroids 8. Where was that? Computer. Oh, of course, 2D arena. Okay, Alrighty. Space Arena 14 FS. That's what I want. Space Arena 14 FS. This is what I want right here. Pretty sure that's what I want. So what we actually want from there is the matrix, cosine of the rotation, P cosine, negative P sine, P sine, P cosine. There we go. And then what we want to do is GLP rotation is GL point coord. Okay, so then we want to take the coordinates, which are the would it be a position? So when do we apply the rotation? After the scaling? So we put them in place, we scale, then we rotate. So here's the scale, then we rotate, so new position equals new position times the matrix. Scale and then rotate. And then here is your world transform. Let's see what that does. Uh-oh, errors. Ambiguous overloaded function mul. Mul? Line 26. Oh, wait a minute, what? Oh. Oh, because this is a matrix 2 by 2. We're actually only interested in transforming... Okay, hold on. Can I do this like new position equals new position plus vector 2 x offset y offset? One or zero or whatever it was, zero. Zero. It was zero. Okay. So I took the z coordinate out because we're actually not transforming the z coordinate. There we go. So, okay. So this just local rotation. It's just a local rotation. So this is a local scale. This is a local rotation. And then this is the world transform. Okay. What I really want to do is the world rotation in relation to the center of the screen. Oh, so that would be up here. That would be your x offset and y offset. Oh. So let's take this out temporarily. So let's transform the offset. Let's go vector 2. We'll call it W offset for world offset. Actually, let's just go world offset equals vector 2 x offset y offset. So before the world transform, let's do a world rotation. So then we'll just go world offset equals world offset times m. So now we'll see what that looks like. Let's see that. Oh, wait. Okay, hold on. World offset equals world offset. So right here, okay. I should apply the transform. Okay. Okay, cool. So the world is transformed, but they're not transformed. Okay. Now what we want to do is apply a local rotation in the opposite direction. So let's put the local rotation back in. But I know we want to do it in the opposite direction, but let's just see what that does. See? So everything is rotated clockwise, but each one is rotated counterclockwise the other way. So So the local rotation is going to be that's why I had this code. This is some funky sound in Zelda, let me tell you. Hateno Village. It's almost over. Okay. What's the next one? Coming up, it says Legend of Zelda. Yes, it's from Game Chomp's Radio. So, okay, rotate the grid points grid spot. Don't I do another rotation? Because there's that one. So with this one, so let me think. What we wanted to do is I'm too Zelda and chill. I'm too Zelda and chill right now. It's happening. Okay, so the rotation there. So we need a separate rotation for the local, or can we go? Can we just go negative M? Too good to be true. Too good to be true. It's gonna be too good to be true. Oh wait, no, that's too much. So let's call this WM. Excuse me. So then, okay, let's think about this. If it's rotating 45 degrees that way, the other one's rotating 45 degrees the other way. And what we want to be reversed is I want to flip it on the x-axis. So x, y, x, y. So don't. So local not 2. So isn't it negative p cosine, comma, negative p sine, comma, p sine, comma. Oh wait, then this will be negative. Would that work as the LM? Local rotate, LM. I don't think that's going to work, but it'll be interesting. There's an error. Undefined variable M. Oh, right, okay. So this is the world. Okay. No. That does not flip it on the x-axis. Oh, wait a minute, duh. I think I can do this without doing that. So after we rotate there, new position.x equals negative new position.x. Because we just want to flip on the x-axis. There we go. Does that work though? All the time? So what if we send in the rotation as a uniform and send it as time? So shader, the shader, or just set float, and we're just going to call it the time. Get GLFW time, or no, it's GLFW get time. Is that right? So we'll send it in there. And then we'll go into the vertex shader. So we'll have the time, and then the rotation will be that plus the time. So that'll show us as it rotates, and we'll see if it looks what it looks like. I believe. I believe. Okay, so that's trippy. So we have the world rotating the other way. And the grid, okay, so that's not what I was thinking would happen. That is not what I was thinking would happen. You guys want to watch this for a while? What do you think? So what if we don't do that? And then are they both rotating the same way? They are, but oh my gosh. Oh. That makes me kind of dizzy. That makes me kind of dizzy, I'm afraid. Okay. I'm afraid. Please don't do that again. Alright, well the scale was 0.25. Let's, if they're all touching, will that be, it'll be a touching scene. It'll be tender and touching. Does that look better? That looks bizarre. But they're all rotating the same way. Why does it look so bizarre though? Why does it warp? I wonder why that warps though. Like, I feel weird. Just looking at that, I feel so weird. That's psychedelic. Hold on. Okay, so why does that look so weird, I wonder? Maybe because they're so big? Let's scale down to... Getting closer. But the world offset is way out there. Bum bum ba-dum ba-bum ba-dum bum ba-dum bum ba-dum ba-ba-bum ba-ba-ba-bum bum ba-bum ba-bum ba-ba-ba-ba-ba-bum ba-dum bum bum ba-bum ba-da-bum. Okay, and this is off because, this isn't how I would calculate it if I was sending in the data and doing this with the center and the, so, local scale, local rotate, world rotate, So if the scale is 0.05, and we're doing 6 of them, that's 0.3. Okay, I think we're getting warping because of the aspect ratio. So why don't I fix that? I don't think we need to change the offset. We need to change new position times scale. We can make a vector 2 scale, vector 2 aspect scale equals vector 2 0.05 0.89 or 0.9 0.89. Oh wait, can you do that? Or let's just... Sorry, I don't think I can do that. A position dot y times... So let's just change the two scales. Is that right? It is, except for this. So the y offset, should I? No, I think this is correct. Those should be the same scale there. All right, well, trial and error. Just there's something, it's not centered. Why is it not centered? Does that have to do with this calculation? Now what if this one is Y scale, by the way? Let's just try it. I want to see. I think that'll make them separate. No? Oh. Weird. Interesting. And I think it's the other way around. No, it's not, is it? I wonder why it looks so warpy. I don't have any ideas. Ah. Well, I was not expecting a warp like that. See, I do multiply y times that. Maybe this one is like that, and then this right here. Just guessing. Well, it kind of warps. So in the other one, do they warp? I don't think they look warped. No, they don't look warped. Yeah, the only thing I do is right there. So this is rotation of the, right. Right, that was just to determine whether they're visible or not. Okay. Huh. Why doesn't it... See, these look perfectly scaled and rotated. I don't see there's warping. Maybe it's the graphic? So let's go into the... Okay, we have the texture coordinates there, but we can hard code them in here to get like one graphic. What was that one? Space D&D Asteroids 8. FTX times that. Okay. Plus XY. Okay, so let's take this code. Whoops, we're just going to go here. Whoa, sorry. All right, Visual Studio Code. My apologies. Sheesh. Oh, let's go here. Julian Camerata. Hey, welcome. Hi, what are you working on today? Well, I can show you real quick because I'm trying to get these asteroids that I had before, and I'm trying to take the rotations from the CPU and put them onto the GPU. I'll show you. So I have these asteroids and they're quads, instance rendered, and they're like little grids. And then they're rotated on the point here too, so they're all kind of grouped together. And what I want to do is, instead of doing all that on the CPU, I'm trying to put it through the geometry shader today, and so far I'm kind of succeeding. So ftex is supposed to be that times that, plus this. This is the offset. So x equals, okay, f-type. So here's what we want to do. Let's just choose from this graphic. Let's choose 3 or 4. Let's choose 3 or 4. Let's just go, it's supposed to be a float, 3. Actually, let's just hard code that. Float. We can use that. So let's see if that'll give us the third one. So that'll do X, Y, that'll do that, that'll do that. And then text color equals that. Actually, here we're going to put the frag color. Let's see if that works. I have never worked with shaders. They are hard. They can be. And Geometry Shader is kind of new to me, but I have done some stuff with it. It's kind of really cool, actually. Okay, let's see what that does. Oh. So, that looks like it worked. It is warping, though. It looks like it's warping. See, like, in and out. I still can't figure out why is it doing that. Oh my gosh, if you look at that long enough and then you look away, it's... Okay, hold on, I gotta reset my... I gotta reset my vision here. Whew, that was different. My apologies, folks, if you looked at that and... Whew, that was... Okay, I'm still feeling it. Okay, alright. Breathe deeply, here we go. What is causing that? Oh... Whew. That's hilarious, kind of. Anybody know what's causing that and how to fix it? So I thought it was this. So I wonder if I shouldn't apply it to the world offset. Okay. And then we're just applying it to the local scale. Okay. Not going to run it for very long this time. Okay, there's still a little bit of warping. And I know this is X scale and the Y offset here, I know that. World offset. If I think this is difficult now in the vertex shader, what kind of trouble am I going to have putting this in the geometry shader? I don't know. Local center offset. Oh, I never do this. Oh, I never center it properly. Okay, hold up. Hold up. So it has to do with this. These offsets. Oh. Is this x scale divided by 2? Negative? Is this negative x? And should I, well, let's just see if that works first before we scale, there. X scale, negative, whoops, oh, sorry. Why does that, why does that do that? Oh. So we know there's going to be 6 of them. What if we take this out altogether? I just want to see what that does, and then that'll probably... Yeah, so then it's centered around here. Everything's... But this is kind of... I don't think that this is... I don't know I don't know what it's doing. I really didn't expect this. I expected different troubles, but not this. Okay, first of all, let's start over again and just take out that and take out that. And then so we'll have the world offset, new position, just have the scale and the world offset. Save that. So computer, show me that. Okay. So to have that absolutely in the center, so then, excuse me, so then we take the, so float x off start is going to equal, so 6 times x scale divided by 2, so 3. negative. Float y off start is going to equal negative 3 times y scale. But does the aspect ratio apply to the offset start? If we're not applying the aspect ratio to the scale, no. So that's an x scale, and maybe that's the problem, but let's try that. So let's go x off start plus, and then y off start plus. Okay, that's more in the center, I think. That's in the center. Okay. So I didn't do that before. So now if we apply the local rotation and the world rotation, and the scale is now just being applied, the aspect ratio is only being applied when we scale locally. When did we apply the aspect ratio here? Apply aspect ratio. So what I did here was local center offset. So the block position is actually equal to the local center offset minus m times the size, n times the size. And then I do the rotation, TP equals D&D block position. And then I do the rotation. So I do the center. Okay. So I do all the transforms for the local, and then I rotate it. Then I do the world rotation and apply the world offset. Okay. Did I save that? Okay. No, it's still warping. Why is it warping? Why is it warping? I don't know. Alright, so I might just take a break right there because I don't know why it's warping. Like, even if we put the Y scale here, I don't think that will work. Let's see. No, that throws it off. It's off. It's not centered. It's not rotating on in the center anymore. So, and if we put it here, whoops. So if we put it there, that won't work either. Because it's not, yeah, see, that's even elongated. It's not not a square anymore. World offset equals that. What do we put it here then? But I don't think that's where it goes. No, that's elongated. Interesting. And if we take it out there, oh, wait a minute. So here's the rotation. Then I applied the aspect ratio. Applied the aspect ratio after the rotation? So should we rotate and then scale it? Hold on. Hold the phone. That would be crazy, but let's do it. So that applies the scale after. Oh, now we get an error. Undefined variable, new position. Oh, whoops. Computer, what are you doing? So then up here we have to vector to new position equals a position dot xy. We're getting a lot of cool effects. We're getting a lot of cool effects, but I don't actually know. All right, well, I don't know. I'm just gonna sit on this for a while. It's been, what, 74 minutes? Okay. We got pretty far. What we started with, we still have. We can start from scratch again if we need to. Might need to. This is pretty interesting. Got the texture in there, got the uniform in there. Anyways, thanks for watching. Nice to meet you guys. Harukat Jiggy and Julian Camarada. I wish I had more to say, but I'm gonna let this kind of stew in my brain until I figure it out, and then I will be back. I will be back.